Imagine a drone no bigger than a shoebox powered by smartphone parts and batteries you'd find in a power drill flying through the thin atmosphere of another world. What started as a 30-day tech demo turned into a 10-on-4 Sol survival saga, ending with the first aircraft crash ever recorded on another planet. But that's not where the story ends. This is the journey of Ingenuity, the little helicopter that redefined exploration, defied expectations, and pushed the limits of science fiction into science fact. Today we'll relive every triumph, every terrifying failure, and every ingenious hack that kept her alive on the red planet. And in the process, you might just realize that sometimes the biggest breakthroughs come from the smallest machines. NASA's Jet Propulsion Laboratory isn't exactly a place where radical, untested ideas thrive, at least not without a fight. Ingenuity's journey began as a wild concept. Could a rotorcraft fly on Mars where the atmosphere is just 1% as dense as Earth's? Many at NASA thought it was a distraction. Kenneth Farley Project, scientist for Perseverance, admitted he saw the mission as a waste of time. Spending 30 days working on a technology demonstration does not further the goals directly from the science point of view. But the scrappy team behind Ingenuity had a different vision. With a budget of just $80 million less than the cost of the film The Martian, they set out to build the first aircraft to fly on another planet. The parts off the shelf, literally, an Android smartphone brain, lithium-ion batteries from a hardware store, a 13-megapixel camera like you'd find in your old phone. Yet with some tweaks and testing, it became one of the most daring projects ever launched into space. In 2016, a prototype was born. In 2018, it was greenlit. And in 2021, it rode to Mars under the belly of the Perseverance rover. Sol 58. April 19, 2021, Ingenuity's twin rotors began to spin 2,400 revolutions per minute, and she lifted off. For 39.1 seconds, she hovered 3 meters above the Martian surface, a moment that echoed the Wright brothers' first flight 118 years earlier. She became the first powered aircraft to fly on another planet. In the following days, Ingenuity flew again. Then again, 5 flights in a month. The original mission had been completed. Tech demo successful. But something strange happened. She kept working. NASA said keep going. So Ingenuity was no longer just a demo. She became a scout, a tool, a teammate for Perseverance. Her new mission chart terrain too dangerous for the rover. Capture aerial imagery, provide data to guide future decisions. Up until that point, every flight was rigorously simulated. Terrain maps were precise, every detail controlled. But now she had to keep pace with a rover that was itself exploring uncharted territory. Mars is over 56 million kilometers from Earth at its closest. Communication delays mean it's impossible to pilot Ingenuity in real time. Each flight had to be programmed in advance and flown autonomously. But without GPS, how does she know where she is through visual navigation? Using a black and white downward-facing camera, Ingenuity captured 30 frames per second. She compared each image, identified features, rocks, ridges, shadows, and determined her movement. Like a flying optical mouse. It worked until it didn't. Flight 6. For the first time, she flew outside her mapped testing area. Mid-flight, a glitch. A color image interfered with a black and white frame thrown off by a late-stage hardware addition. One skipped frame caused all subsequent data to lag behind. Her onboard computer believed she was always behind where she actually was. So it pushed her to compensate. She began to wobble, up to 20-degree swings. Emergency systems activated. She landed hard but safely. A software patch fixed the bug. Ingenuity flew again. Then came Flight 19, scheduled, ready, but a storm was brewing. JPL received a dust storm alert. Flight canceled. Ingenuity hunkered down. For 6 days, wind battered her body. Dust settled on her panels, reducing solar input by 18%. Worse, it jammed her servo motors. The team's workaround wiggled the servos until they moved freely. It worked, but the problems piled up. Nights on Mars dipped to 133 degrees C. Heating her internals consumed 60 to 75% of her battery. If the power ran out, she'd freeze. On May 3, 2022, she went dark. No signal, no telemetry. The team feared the worst. They realized if her batteries had drained, her internal clock would reset. She'd wake up, but at the wrong time. They recalculated her new sunrise, and at 11:45 a.m. Martian time, they pinged her. Response: she was alive, except one thing had died, her inclinometer. Without it, she didn't know her orientation. No flight. Then came an idea: use the IMU inertial measurement unit from her smartphone grade parts. They reprogrammed her code. It worked. She flew again. With spring came more light, more power, more missions. Ingenuity flew higher up to 24 meters, flew faster 10 meters per second, captured images of craters Perseverance couldn't reach, conducted test after test, set records in distance, speed, and endurance. The mission became one of exploration science and aerial engineering on another world. She became the Martian Pathfinder, and then, Flight 71, she crossed a sandy region with a few visual markers. Without enough surface features, her navigation became erratic. Emergency landing, damage none visible. Flight 72, she rose again, scanned the area, and descended. Same problem. Only this time she hit hard. Perseverance photographed the wreck. Blades snapped. A mission-ending failure. Post-crash investigation found no ground. Her blades didn't hit horizontally. They bent and broke from torsional stress. The cause: precession torque, a physics phenomenon where spinning forces shift 90 degrees from the applied force. Ingenuity didn't die in vain. Her parts off-the-shelf electronics lasted nearly 3 years, surviving dust-cold storms and cosmic rays. She proved that commercial hardware could be space-hardened through testing, not just shielding. Her success paved the way for Chopper, a larger 6-rotor orbit-linked helicopter that can carry science payloads independently, no longer tethered to a rover. Soon, there will be airports on Mars, fleets of explorers, aerial surveys, fast science, because of Ingenuity. A piece of the Wright brothers' first plane was stitched beneath Ingenuity's belly. From Earth's first flight to Mars's first aircraft crash site, history echoes across worlds. She was a tech demo that wasn't supposed to last, but she flew 72 times, logged over 17 kilometers, and redefined what's possible. And even now, silent in the dust, she functions as a weather station. Her sensors still record temperature, still send data, still alive. This isn't just about a drone, it's about how far we can go when we dare to imagine. Let Ginny's story remind us no idea is too small to change the world or another planet.